Hello. I'd like to start looking at the future by looking at the past. Several hundred years ago, when Europe went through a time of massive transformation in scientific thinking, we called it the Scientific Revolution. And one of the major contributors to that was a gentleman by the name of Sir Isaac Newton. He's a physicist, utterly brilliant. He gave us things like gravity. But he also had the humility to recognize that in order to move forward and in order to do the things he was able to do, he needed to learn from the people who'd gone before him, to learn from the past, to stand on the shoulders of giants. So I believe, and Dr. Fei-Fei Li, who is sometimes referred to as the mother of AI, that we are at a similar inflection point in history and scientific thinking because of AI. And so the question becomes, whose shoulders do we need to be standing on as we go forward? There are many options, obviously, but one of the people I'd like to recommend is actually a 19th century physician by the name of William Farr. Who's William Farr? Well, he was, in addition to being a physician, a statistician. He was a medical taxonomist, and I'll talk more about that in a couple of minutes. He was an epidemiologist. He did some of the pioneering work around occupational medicine and around the social determinants of health. He was a data scientist. He was brilliant about turning raw data into useful information to help us understand healthcare. But his day job was compiler of abstracts for the General Register Office. Boy, does that sound boring. We know him mostly because of the contributions that his work made to solving the mystery of what led to cholera and the London cholera epidemic. That's still one of the greatest public health stories we tell. It's made it into popular culture as well as medical history. So what can we learn from Dr. William Farr? Well, I think we can learn 6 things. We need to understand the opportunity that's in front of us. We need to identify the information necessary to make that opportunity real. We need to collect and normalize that data and counteract the bias that we're likely to introduce in it. We need to make it meaningful to the people using artificial intelligence, and we need to learn from one another. So, how does Dr. Farr teach us about understanding the opportunity? Well, in 1837, England passed a law that said that on an annual basis, they would collect statistics on births, marriages, and deaths. Dr. Farr, who was appointed the first person to do that, recognized that this was more than a bunch of numbers. That if used properly, this data could help us understand the patterns of mortality. It could help us understand the differences in mortality and disease rates by population density, by occupation, by gender. And we could start to understand how to prevent disease instead of just trying to cure it. And especially in those days, they didn't have a lot of the cures we have today. Well, we're at a similar point. We need to understand the opportunity in front of us. The analyst firm Gartner has commented that if you know their hype cycle, where they talk about things moving up to the peak of inflated expectations and then down into the trough of disillusionment, generative AI is the only technology they've ever seen that started its path on the hype cycle at the peak of inflated expectations. There's so much hype around this that it's meaningless. And a lot of people are kind of lost in it. So I want to do a quick review of terminology before we move forward. The term artificial intelligence is more than 70 years old. It was coined by Alan Turing. And it was the idea that we could teach computers to think and reason the way human beings do. Normally, from a commercial standpoint, we deal in narrow AI, which means we're not trying to make it think about everything, but we're trying to solve specific problems by teaching the computer to think. We usually do that with statistical models that will try to look at the patterns in data about what's happened in the past. It's called machine learning. And when we apply a more complex strategy to that using artificial neural networks, we're getting into deep learning. What's really exciting is when we start to say we're not just looking at the patterns of what happened in the past and predicting the likelihood of something, but now, in fact, we're able to create new data that looks like the old data. The trouble is generative AI, that concept of creating new data, is limited by the training sets we have. So one of the big breakthroughs of the last few years, and that has caused all the buzz, was a new architecture for this kind of training data called the transform architecture. Think about the T in transform in just a moment. That enabled us to build training sets of millions and billions of parameters, or the large language models we talk about today. And that then allowed us to create generative pre-trained transformers, GPTs, that would create new content based on natural language. And now we had massive sets of training data to use. Now, when you hear GPT-4, that is simply a brand name. It comes from OpenAI. It's their version of a GPT. It's model number 4. And they put over that a user interface called ChatGPT. You may also have heard Google advertising its Gemini application. Lots and lots of these are coming out. But ChatGPT is simply a user interface over a branded version of a generative pre-trained transformer. Now, the thing that's valid for all of these things, and I'll move out of my own way here, is that your AI is only as good as your data. If your AI does not contain patterns of data that are consistent and similar to what you're trying to learn from, it's not going to be as effective. So let's hold that in mind for a moment. I went through that really fast. You may want to learn more. So my colleague Jeff Fried, my colleague Don Woodlock, both do a lot of educational activities on this. They post their content. Don has a YouTube channel or a LinkedIn channel on this. I think he also has a YouTube channel. Great content if you want to learn more. I'll give you just a moment. Okay. So I said we need to understand the opportunity. Part of that involves understanding what AI is, but part of it involves sitting down and thinking about what's your role. Well, InterSystems has been doing that as well. And going back to that comment about AI is only as good as the data, we believe that a lot of our role is, in fact, to make sure that we deliver the capabilities for managing data that lets you take advantage of AI capabilities and build out your own solutions. We need to build them into TrackCare and into HealthShare, the solutions we deliver for you. Secondly, we need to use Gen AI actively in our own activities. So we've been working with our learning services, with our documentation teams, with our support teams, and how we can leverage AI in our own operations. We need to seek out truly innovative solutions and look at how those can create sustainable difference, both for our business and for yours. But the most important thing we need to do, and Paul Grabscheid will talk more about this, is serve you as a valued and trusted partner as you embark on your AI journeys. So what is your opportunity? Are you looking to train a model that somebody else has developed on your own data? Are you looking to employ machine learning and add predictive models to your EMR, to TrackCare? Are you looking to take the data out and do that? Are you looking to build whole new solutions, digital health solutions that are AI enabled? Are you looking to solve a business problem by plugging in somebody else's third-party AI-based application into your EMR, into TrackCare? Whatever that is, you're going to need to start with data. So the second thing we learned from William Farr is that you've got to really think beyond the bare outlines of the problem and consider what your opportunity is to go further. He recognized that if he collected information, for example, on the weather, if he inferred information about population density and compared that with death rates, if he looked at the occupation of a person who died, he could derive a whole lot of additional information from the data set that he was charged with compiling. Similarly, we need to think about what information is available and relevant and useful for your goals. So what are the sources you can use? There's your EMR data, there's your customer relationship data, there's business and genomic data, there's public data sources around demographics and environment, there's your device data, all those wearables we now have. How consistent is it if you're bringing data together from multiple locales? Is it consistent? Is it going to be widely different? How complete is it? What's the quality of the data you've got? What are the formats and characteristics of that data? You're going to have data management capabilities to manage many different types of information. We try to be really good at that. But you need to make sure you can accommodate all those different data types and really consider the breadth, the diversity, and the scale of the information you're going to use. Okay, so we've identified the information we want. Now we have the problem that, in fact, it's not normalized. The information that William Farr got was handwritten from all over England. It had things that were like died of consumption. Consumption isn't a very precise term. And we didn't have the same kind of precision in medicine then that we have today. We don't have the precision today that we'll have tomorrow. But William Farr did something very brilliant. He created what he called a nosology. It's a taxonomy. He mapped together related conditions. He grouped them, and you use them today. Because the work he did led directly to the ICD, the International Classification of Diseases. We've heard a lot this morning, and I won't emphasize it again, around interoperability and how important it is. But you're going to be taking data from many sources. You have to make sure that your sources and your receivers can interpret that data the same way. I won't belabor the interoperability issue. Again, data management. This is what InterSystems' bread and butter has always been, is helping to manage data at scale, multiple formats. And standardization. It's more than just code sets. My name is Kathleen Clapham-Aller. If you have a source over here that's Kathleen C. Aller, and another source that's K. C. Aller, and another source that's K. Aller, and oh, by the way, there's a Katie A. over here. Is that all my data? My physicians, my nurses, my patients, their families, I need to know they're the same person if I'm bringing that data together, or my results are going to be horrible. What are the formats of the data? Do you need to take screen-scraped PDFs and turn them into discrete data elements that are mapped to code sets? You got to think about all that data collection and normalization. We need to learn from Dr. Farr about bias. Now, most of you, if you've ever heard the story of the London cholera epidemic, have heard about a doctor named John Snow. He's the one that's contributed the solution. But he based it on Dr. Farr's data. Dr. Farr collected all the data to understand what the source of cholera was, but he was influenced by his preconceptions. He believed in something called the miasma theory, that you had bad air that caused disease, and that if you went higher up, you had better quality air than you had lower down. This is a painting from the era about cholera tromping all over everybody. He believed that air was what caused the problem. When Dr. John Snow proposed his theory that dirty water, contaminated water, was what led to the spread of disease, Dr. Farr led the commission that said, nope, we don't think so. And because of his bias, because of his misinterpretation of the data he collected so painstakingly, thousands of people died who did not need to, because it took a number of years before they came back to it. We still have problems with bias today. We have it affecting the standards of treatment we use. It gets into our medical devices. It's into our clinical trials. It's into the algorithms we use in our software, and it will infect our AIs if we are not vigilant about it. Pulse oximeter works really well if you have light skin, not so good if your skin's dark. All kinds of similar models. Dr. Midell Briggs Mallinson of the University of California spoke at InterSystems Global Summit in June, and she did a great job of talking about the nature of bias and the way it can affect AI. And she talked about bias data collection. If we have incomplete data, it's going to skew the results. If we have historical bias, it will also skew the results. So think about if you collect data on the assumption that there's very little public insurance, and then you move to a universal insurance model, the assumptions you've made are going to be wrong. There's sampling bias. The population you've sampled doesn't look like the population you're applying the model to. Body mass index was developed on Dutch men 100 years ago, and we use it today. Now it's been updated, but it's out of whack. Here in Asia, this is particularly important because so much of the modeling that's done is happening in the US and in Europe. And then there's measurement bias. The devices are wrong, or we're not capturing it accurately. On top of biased data collection, we have biased interpretation of data. This is what William Farr was guilty of. He had the right data. He had very complete data for the time, but he misinterpreted it because he believed in the miasma theory. And then we have the interpretation of biased data, which gets really complicated and beyond the time we have available. All right, what else can we learn? Well, Dr. Farr and Dr. Snow were both really good at making stories out of the data, making it meaningful to people. This is the famous London cholera map. It plotted where people died. It plotted where the water sources were. It was very effective at showing the problem and the transmission of disease. This is a map or a graphic you may not have seen before. It maps cholera mortality by elevation. And Dr. Farr used this to show that his miasma theory made sense. In reality, though, it still does a nice job of illustrating that if you're further upstream, high up on an elevation, you're getting the cleaner water before it's been contaminated down at the mouth. Right data, wrong interpretation. Both of them help to represent the data. Similarly, as we deploy AIs, we have to think about making them meaningful to people. Transparency is where we're very upfront and open with people about how we collected the data, why we chose a particular model, what it means, how we're deploying it, how we're maintaining it. Explainability means that we can make it understandable to people. They can understand how the model is reasoning, and that builds trust and confidence in using it. And traceability lets us track how decisions are being made. I think Dimitri will be showing you some examples of traceability later on. All right, we need to learn from one another. I said that Dr. Farr got it wrong. Dr. Snow got it right. Dr. Snow based all of his conclusions on Dr. William Farr's data. And the good part is that William Farr was enough of a scientist to say, okay, I've rejected what this guy said, but I'm going to go back and look at my data. I'm going to keep capturing it. I'm going to expand my data set. And within a few years, He had changed his mind, and he recognized that, in fact, water did contribute to the transmission of cholera, and he was part of leading the effort to solve the problem. So he learned, he was willing to be collaborative, he was willing to partner. Who can we learn from? Well, obviously, for those of you who are TrackCare customers, we want to learn from other TrackCare customers. One of our longtime customers in Saudi Arabia is King Khalid Eye Specialist Hospital, sometimes referred to as KKESH. They were one of the first hospitals in the Middle East to be certified at HIMSS Level 7. They had a problem, though. They had a high number of no-shows. So they would make appointments. People wouldn't show up for that appointment. They wouldn't be getting revenue. The doctor would be frustrated. And oh, by the way, those patients who were on a wait list for an appointment were having to wait longer. So they came to us and they said, can your data scientists work with us to help us develop a model that will predict this and help solve the problem? And we took the data out of TrackCare and we pushed it into IRIS. We used the capabilities of IRIS to help develop that machine learning model. And they came up with a predictive model that said, yeah, these are the patients most likely to fail to show up for an appointment. They then built that into their registration system, and they used it to change the way they confirmed appointments with people, the way they followed up. They focused on those people most likely to not show up. Those people were then able to say, no, I'm not going to be able to come. They could reschedule other patients into those slots. They reduced their no-show rate by 40%. Great example of a business problem that we use clinical data to help solve. Bay State Health. I spoke last year at our Asia Summit in Thailand, and I talked about some of the work we were doing with a hospital not far from our corporate headquarters in Boston. Bay State Health had a patient portal, has a patient portal, and they asked us to look at the messages they get from patients to see if we could automatically identify, using machine learning, messages that were urgent. Patients aren't supposed to put urgent messages in the portal, but they do it anyway. So we did some training, we got some good results. I shared those last year. Over the course of the last year, we've been working on that model with them. We've increased the accuracy to 95%. We've fine-tuned it. We've looked at what are the right thresholds to put in place. We've deployed it in a pilot operation. And we've worked through a number of operational and governance issues. One of the things we learned is that the IT is the easy part of this. It's taken almost a year for the lowest imaginable risk machine learning model to be put in place in that organization. The board had to get comfortable with it. The organization had to figure out how to do this. And while we don't think it's going to take a year for the next model, we have to build into our expectations the time it's going to take to change our thinking at the administrative level as well as at the IT software development level. We needed to build in time, and we needed to figure out frameworks for helping the staff get used to this. They needed to understand how the model worked, going back to that transparency I talked about. They needed to understand how it collaborated with them, and that it was not, in fact, a threat to their jobs. This is a better together model, not a we're going to do it instead of you. We needed to iterate through and train the model further because there were a couple of challenges. We might recognize that something was urgent because it discussed an asthma attack, but the patient may have said, I had an asthma attack last week, it resolved, I'd like to come in for my next appointment in 2 weeks. The model didn't recognize that. It saw I had an asthma attack and tried to schedule you to go in. So we had to teach it that. It required iteration through. Secondly, there were certain characteristics they wanted, like anytime chest pain was mentioned, that became an urgent appointment. So we built that in as a fixed field within this framework. And finally, we learned that while users grumbled about having too many patients identified as urgent, they preferred having too many than missing some. Now, I think that'll change as people get used to this stuff and as they get other alerts. But right now, they were more comfortable with that. So how did it look in practice? It's a very simple thing. We put a star on patient messages that are urgent. They sort them to the top. There's nothing fancy here. Sort them to the top of the work list. Those are the first messages that the customer service reps see. We recently, in fact, while I was putting these slides together, got an email from the customer, and they said, hey, you know, we had a patient recently who sent us a message, in the message, where they only asked, can I schedule an appointment, a standard appointment. They mentioned that they'd been feeling chest pain. Got tagged as urgent, brought to the top of the list. They got the patient in right away for a visit. Patient came back and said, hey, I want to send you a thank you note because this was really great. They said they'd never had that happen before. So it was great for customer relations, and they got a patient into care who needed it. And finally, if what you're building are solutions, new digital health solutions, you may want to talk to some of the organizations that are beginning to use our technologies to build out startup companies. We have a great accelerator program that's based in Prague. It's an international program. We have companies here. Jonda Health, Marymount Labs are both here. They're all using capabilities from InterSystems Iris to build out new digital health solutions that are AI-powered. So, what did we learn from our giant William Farr? We need to understand the opportunity that AI represents. We need to identify the information that's going to help us take advantage of that opportunity. We need to collect and normalize data to make sure it's high quality and recognize and overcome the bias that we all have. We need to make our AIs meaningful to those who are going to use them, and that helps reduce the fear and increase the trust. And we need to learn from one another. This story continues to resonate, the story of William Farr, of John Snow, of the cholera epidemic. There was a fairly recent paper that took the same data set that they'd used back in the 1800s, and they applied linear regression to it. Now, linear regression was not available in the days of William Farr. He was a great scientist, so odds are he would have used it if it had been available. What the paper found is that if he'd used linear regression, they would have identified the relationship between contaminated water and disease and solved the problem that much sooner. Similarly, you, the healthcare leaders of today, along with William Farr and John Snow, are creating the future at breakneck speed. We all need to learn from those who went before us, but we need to learn from those who are walking alongside us. And in particular, InterSystems wants to be there to help you as you chart the course for the future. So thank you very much.